Alright, so we're going to finish up today with 10.2. I think since tomorrow we meet at 10, we have class 10 to 11 tomorrow. We have about an hour, so we'll get through most of it today, but I'm not going to go through it fast just to finish it. Okay, so we might have a little to finish tomorrow. Right, so what I want to do is just kind of review quickly an example that we would have done last time. And what we're going to do is use one equation to eliminate a variable in the other two. Specifically, you don't have to figure out what to eliminate. Okay, I'm telling you this time, I want to eliminate x. After we eliminate x, then we're going to eliminate y. Okay, so let's do x first, then we'll do y, and then we'll get our answers. Okay, this is going to be the old way of doing it, just a review of what we've already done. If we didn't have enough time, I would skip reviewing it, but we got enough time. Okay, so there's our equations. And even if they didn't tell you what variable to eliminate, you generally want to look for a variable that has what number in front of it? Look for a 1. Okay. I see a couple with 1s. Okay, we've got some x's with 1s. We've also got a z with a 1 over there. So I think you could have done x or z, but they asked us to try to do x. Let's number these equations. And let's try to get rid of x in equations 1 and 2. Anytime I write a number and circle it, that means it's an equation. All right, so we've got x minus 2y plus z equals -1, and 2x plus 3y minus 2z equals -3. Does anyone see what I could multiply the top equation by, and it will get rid of my x? You don't have to multiply by the bottom. Yep. -2. Okay. So let's multiply that whole thing by -2 and see what we get. So we get -2x plus 4y minus 2z equals -1. In the bottom, we're going to keep it the same. So Jackson, when I add these up, can you tell me what I get for my new equation?
Yeah.
Let me double check everything here. 1 second. No, that's right. That should be a 2. Thank you. Okay, so we caught that before anything went wrong, which is good. Thank you. Go ahead. Can you tell me now what I get when I add them up?
7y minus 4z equals 5.
7y. X's are gone. Okay, so let's start with that. Then he said 7y minus 4z equals 5. Perfect. We're going to call that equation 4. We're not going to do anything with equation 4 right now, but we're going to come back to it in like a minute. Why is it not? That was my fault. I think I erased it and I didn't copy it back down right. So it was -3 here. It should stay exactly the same. Any question on that? I just copied it wrong. Sorry about that. Okay, so we used equations 1 and 2. We can't use 1 and 2 again, so let's do something different. Now let's do 1 and 3. And it's going to be the same goal. Get rid of the x. All right, so equation 1 is x minus 2y plus z equals -1. And if you notice I copied anything wrong, please let me know. Equation 3 is x plus 3y minus 2z equals -2. Okay, and we want to make the x's cancel out. So what could I multiply? And actually, you could do either equation this time. Doesn't matter which equation you pick, you'd multiply by the same number. Yeah? Yeah, let's just do -1 in the top. Let's copy the bottom, because that stays the same. 3y minus 2z equals -2. And when you multiply by -1, it just changes the sign of everything. So -x plus 2y minus z equals 1. And Gavin, can you add those up for me?
Would it be -1y and no, sorry, 5y.
Yep. 5y. X's are gone because that was a -x and a positive x.
-3z.
Yep. Good.
And 1.
And 1 minus 2 is
-1.
-1. All right. So now we've got another equation that only has a y and a z in it. We've taken our problem that had 3 variables. Now we turned it into a problem with 2. So we're going to take those 2, and we're going to try to get rid of either y or z. I guess I would try to get rid of the z's. You're going to have to multiply both equations by a number no matter how you do it. So let's take equations 4 and 5. Yeah, I don't know. I don't know which way is better. If you want to get rid of the y's, you're going to have to make one of them 35 and one of them -35. If you want to get rid of the z's, you're going to have to make one of them 12 and one of them -12. So I think if you try to get rid of the z's, you can keep the numbers smaller. Okay. Let's just copy it first. So 7y minus 4z equals -1. 5y minus 3z. Are they both equal to -1? Okay. All right. Let's make the top z a 12. And then we'll make the bottom z a -12. What would I multiply the top by if I want to try to make the z a 12? Okay, so let's multiply that by -3. And what would we multiply the bottom by if we want to make this a -12? 4. Let's try that, and then hopefully we get a nice answer for y, maybe. So we've got -21y. We've got plus 12z equals 3. Okay. We get, all right, that's probably good, 20y, because when I combine these, I'm only going to get a -1, so that's a nice number. So 20y minus 12z equals -1 times 4 is -4. Okay, let's add them up. Ryan, can you tell me what I get when I add those up?
That would be -1y.
Yep, so
And then
-1y
equals -1.
equals -1. All right,
Y
so y equals 1. I think all the answers today come out to nice numbers. So if we get a fraction or a decimal here, we did something wrong. All right, so now we've got y, and now we got to get x and z. That's going to be easy. Let's take either equation 4 or 5. I'm going to go with 5 because the numbers are a little smaller. 5y minus 3z equals -1. And Curtis, what did we just figure out y was? 1. Substitute it in, and we'll have our answer for z. What's 5 times 1 going to give me? 5. Minus 5 to the other side. And Austin, my last step.
you have to divide 3 from both sides?
I get more than that. I want to divide by 3 as part of it.
Negative 3.
-3. And what does that give me for z? 2. There we go. So z is 2. And the last thing I have to find is x. Pick any equation you want. Yeah, that's a good one. X minus 2y plus z equals -1. And fill in the 2 things we know. We know y is 1. And we know z is 2. Alright, so we got x minus 2 plus 2, so that's nice. What happens with minus 2 plus 2? Cancels out. And we're automatically done. X equals -1. So those are my 3 answers. -1, y is 1, and z is 2. Yeah.
We got an x at the very beginning if you was it times 3 and the equation 3 by -1 and subtracted 3 and 2. You could have just gotten x by itself.
Yep, so we're gonna see, yeah, there's lots of different ways you could have done it. But yep. I'm not saying this was the best way, but it worked. But yeah, it's good if you notice that. Alright, any questions on kind of the idea there? Alright, so one thing that's not the best about this method is a lot of what we wrote up there was the letters, X, Y, and Z. Okay, we probably wrote them 30 or 40 times. There's a way we can do this without having to keep writing letters. And that's what I'm going to show you now. We're going to do that problem again. Exact same problem. But I'm going to show you next time how to do it with a matrix. So you can think of a matrix. It's not really anything fancy. It's just numbers that are organized into rows and columns. That's all it is. The way you generally describe a matrix, like if you want to say how big it is, you say how many rows it has and how many columns it has. So for example, if you told me that you had a matrix that was 2 by 3, that means your matrix has 2 rows, 3 columns. It would look like this. That's an example of 2 rows, 3 columns. If the number of rows is the same as the number of columns, then we have what's called a square matrix. So if you said you had a matrix that was 3 by 3, you'd have numbers in 9 different spots, and you'd have 3 rows, 3 columns. We're gonna work with some square matrices when we do some stuff. Each number in the matrix is called an element. So I just make up some numbers. And I said to you, what is the element in row 3, column 2? You would say 10. Element just means the thing in that spot. Okay, so row 3, column 2 is 10. Oh, here's another example right here. A lot of times when we want to give a name to a matrix, just like in algebra when we don't know something, we use a letter. Well, we do the same thing with a matrix. If you look at your graphing calculator, it uses letters for a matrix. Specifically, capital letters. So generally, the name of a matrix is just a single capital letter. If you want to identify a specific element in the matrix, then you use the same letter, except you make it lowercase, and the two numbers you put here represent row and column. So this notation means in matrix A, tell me what's in the second row and the third column. Row, comma, column. Second row, third column is a 9. We're not going to use that notation a ton, but it's something you could see when you do matrices. Any question on that? So we're specifically going to use a matrix to solve a system of equations. There are probably hundreds of things you can do when you put numbers in a matrix. We're going to look at one thing. There's a lot. In fact, there's an entire class in college that's just about matrices, and that's all you do, the whole thing. So what's the point of it? Well, the main advantage is it shortens how much we have to write, and it eliminates you having to think about, all right, should I get rid of x first or y first? Should I use equations 1 and 2? Should I use 1 and 3? You're not going to have to think about any of that. When you solve problems like we did yesterday, people in here could have done it different ways. You might have chosen one thing, somebody else might have chosen something different. Today, everybody is going to solve every problem exactly the same way. Nobody will be doing different steps with this. So that's one thing it's a little different. So when you want to use a matrix to write your equations, each column in your matrix is going to represent a particular variable. Generally, the first column is x. The second column will represent your y. And the third column will be your z's. The numbers that you put in these spots, like these 9, 3 by 3, these 9 spots that I have right here, if we go back to our problem we just did, those 9 spots would be these 9 numbers that I just circled. That's all you would have to write in. All those numbers that are in front of the letters, those are called coefficients. When you organize all the coefficients into a matrix, we call it a matrix of coefficients. It's just all the numbers that were in front of the variables. Now, if that's all you write down, just the numbers that were in front of the variables, then you're going to be missing something. So I'm going to go back to that example we just did. What's still in these equations that I didn't circle? Yeah?
The answer, or the sum of all. The right, the fourth column.
Yeah, this right-hand side, right? These 3 numbers, what it's equal to. -1, 3, and 2. Well, what we're going to do is we're just going to tack those numbers on in another column right there. So that's how most of our problems are going to be set up. They're going to have 3 rows, 1 row for each equation, and 4 columns. X column, Y column, Z column. number that was on the other side. So you take your 3x3 matrix that had all the coefficients, and this word just means add. We're going to add onto it a column for all the numbers that were on the right-hand side. Or I could say in general, all the numbers that were on the other side of the equal sign. They're usually on the right. I think in all the problems we do, they're on the right. So this first step basically tells you how to take the problem and set it up in a matrix. Doesn't tell us anything to do yet, like once we do that. We still have to see what we do with those numbers. But that's the first step. We set them all up. So I'll do a quick example with a 2x2 so you can see how it would look. We're going to do x, y, and z, but just to show you how x and y would look, this is how you'd set the problem up. 2, 3, 7, -5, -8, 12. That's how you translate it from an equation to a matrix. Now, unfortunately, this number is not a 1. If you remember yesterday, I said look for the variable that had a 1 in front of it. We really want to have a 1 here. And I'll show you how you get a 1 here if you don't have it. Okay. Any question on how I rewrote that? So, what is the goal? The goal is to end up, let me show you with numbers first, and then I'll write it. It's something that looks like this. This could be anything. This could be anything. This could be anything. That's the goal. Actually, no, that has to be a 1. So the goal is to end up with a diagonal of 1s and 0s below it. That's what we have to end up with. What's above the 1s, I don't care. It can be any numbers you want. But the goal is to get 0s below. That's the diagonal. Get 0s below and get 1s on it. And I'll show you how we do it.
So it doesn't matter what numbers you have above them?
No, it doesn't matter what's above it.
Alright.
Whatever happens, happens.
Last year, Mr. Rob have everything be 0.
Okay, so he did what's called reduced row echelon form. Row echelon form is the first half.
Mm-hmm.
What you're talking about is also the second half. So we're just going to do the first half. Okay, so that's what it should look like. 1s on the main diagonal and 0s everywhere below. Now I said the goal is to transform. Well, there's rules. There's certain things that we can do and we can't do. So I'm going to show you what you can do to make that happen. And I don't know if you've had other teachers that taught this, they might have mentioned too the name of this process. What we're doing is called Gaussian elimination. It's named after somebody with the last name Gauss, G-A-U-S-S. So that's the name, Gaussian elimination. And the elimination part comes in when you get 0s. 0s mean you're eliminating things. All right, so to get something in what we call row echelon form, we're not doing reduced row echelon form. That's one more step. We're going to stick with this and use substitution. But to get something with ones on the diagonal and zeros below it, there are 3 things you're allowed to do. Only 3 things. And the 3 things you're allowed to do are called row operations. It's the thing you're allowed to do to a row. And they're pretty simple. First thing you're allowed to do is you can take 2 rows and swap them. Swapping 2 rows is basically just like reordering your equations. You're changing which one you wrote down first. It's not a big deal. So you can swap 2 rows. The other thing you can do is you can multiply a row by any number you want, as long as it's not 0. And we did this. We did this yesterday when we were solving equations. We did it today. Go back just for 1 second. We multiplied an entire equation by the number -2. So we multiplied essentially this row by the number -2. So we've done that before. And the third operation says once you multiply a row by a number, you can add it to another row. But yeah, we've done that one too. We added 2 equations together. Usually one of them had a number and the other one had the opposite. So our goal was to always get a 0 for one of the variables by adding one equation to another. Sometimes we had to multiply one equation by a number. Sometimes we had to multiply both of them. So we can swap rows, we can multiply rows by a number, and we can add rows together. And that's all we can do. So my goal is to try to do maybe 2 examples. We'll see. Depends how many questions or if we mess up. If you mess up in the middle of one of these problems, it's bad. Because if you find a mistake, every step builds on it. You have to start over. So hopefully we don't make a mistake. But the first problem I'm going to do is the one we already did. So we already know what the answers are. What were they? -1, 1, and 2. Okay, so we'll just remember those numbers. -1, 1, and 2. So let me copy it down. I don't know if this was the original problem we had. I don't think that was. Let me just, must have changed it. Let me copy it. Okay, so let's change this. So there's what we're going to do. Write that down. I'll get rid of these circles. And good enough. Okay. So first step is to take that and just put it in a matrix. All right. Can somebody tell me what my top row will be in my matrix? Yep. There you go. 1, -2, 1, -1. Sam, how about my second row?
2, 3, 2, -3.
2, 3,
-2.
-2, -3. And Grady, how about my last row?
1, 3, -2, -2.
Good. Perfect. Okay. Any questions on that? Okay. I'm going to tell you the general kind of pattern in this problem, and I'll keep saying it as we do it. You have to go in this order. You have to get a 1 here, which we already have, so that's good. Then a 0 here, then a 0 here. You have to start with the left column. Then you go to the middle. You have to get a 1 here, and then a 0 here. And then you go to the third column, and you get a 1 there. You have to do it in that order. If you don't, what you do in a later step may mess up what you did in an earlier step. We don't want to do that. We don't want anything to mess up something we've already got all set. So let's go through it and focus on the first column. Step 1, get a 1 in this spot. Already have, so that's good. Okay, the next thing, we want to get a 0 right here. So look at row 1, specifically look at this first number, and think, what could you multiply this number by so that it would cancel out with 2? Yeah? -2. So we're going to multiply this top row by -2, and we're going to add it to the second row. Let me show you how you write that. Because I don't want to write that as a sentence. Multiply the top row by -2 and add it to the second row. That's too much. So this is how we're going to write it. We're going to do -2. When you circle a number, it means it's a row. Just like when I circled it, it was an equation. -2 times the first row. And we're going to add that to the second row. And then this arrow is going to mean where we're going to put the answer. Because if you do -2 times the first row and add it to the second row, that's all in your head. You haven't actually put the answer anywhere. We're going to put the answer in row 2. So we are going to replace what's in row 2 by doing that. Now, what's nice about this, and it eliminates one step of copying, we're not only going to get a 0 right here, we're going to get a 0 right here at the same time. So we're going to look back at this top row, and does anybody see what we could multiply the top row by to make this number a 0 at the bottom when we add them together? -1. So we're going to multiply the top row by -1. So -1 times the first row. We're going to add that to what's in the third row. And that's going to replace what's currently in the third row. So that's what we're going to do. Now, let's do it. The top row, once you get a 1 in the upper left, it never changes for the entire row. So I'm going to copy the top row down right away. We're not storing anything in row 1. We're replacing row 2 and 3, not 1. So 1, -2, 1, -1. Now we'll go through each calculation one at a time. negative 2 times the first plus the second. So we have to do that for every number. All right. What's negative 2 times 1? Plus 2. 0. Now do it again. What's negative 2 times negative 2? 4 plus 3? 7. What's 1 times negative 2? Negative 2 plus negative 2. Multiply negative 1 times negative 2. Positive 2 plus negative 3. Negative 1. Let's do it again. Now we're going to multiply everything in the first row by negative 1 and add it to the third. Okay. So 1 times negative 1 plus 1. 0. Negative 2 times negative 1 plus 3. 1 times negative 1. Negative 1 minus 2. Negative 3. And the last one. Negative 1 times negative 1. 1 plus negative 2. Negative. So that's our first step. So any questions how we did that? So what we basically have now is 0x plus 7y minus 4z equals negative 1, and 0x plus 5y minus 3z equals negative 1. So we've eliminated the x variable in 2 equations. Now we're going to focus on that. And we're going to try to eliminate another variable. And then we'll be down to an equation with 1 variable. Okay. Alright, so we got the 1. We've got a 0. We've got a 0. The next thing that we want to do is we want a 1 in this middle spot. Not a huge fan of that 7. But that's what we've got. So we're going to have to work with that 7. Yep.
You have to use the bottom 2 rows for this, right?
Yeah, we're going to just focus on the bottom 2 rows. How could I get a 1 right there? And remember, there's one elementary row operation we haven't used yet. We haven't used swap. We're not going to do a swap in this part. But look at rule 2. Multiply a row by a number that's not 0. What could we multiply this row by that would make this a 1? Yep, that's it.
1, 7.
1, 7. It's not my favorite number to have to use right here, but that's what we have to do. We need to multiply this entire row by 1 7. All right, so let's take row 2 times 1 7. And that's it. That's going to replace what's in row 2 currently. No change to row 1. No change to row 3 this time. Anything that doesn't change, I like to copy it. Get that out of the way. So let's copy row 1. And copy row 3. Right, and let's multiply everything by 1 7. What's 0 times 1 7? 0. That 0 should never change from being a 0 for the rest of this one. What's 7 times 1 7? 1. So that's good. And the rest, I'm just going to leave. 4 times 1 7 is negative 4 sevenths. What's negative 1 times 1/7? Just negative 1/7. Would have been nice if we didn't get a fraction, but luckily we're almost at the end, so we're not going to have to deal with these fractions very much. Okay. We've got our 1, we've got our 0, we've got our 0. Good. We've got our 1. The next step is to get a 0 right there. We're done with row 1. Now we're using row 2. If you used row 1 to do anything, you would mess up these zeros. So don't use this row 1 anymore. What could you multiply row 2 by? And then add it to row 3 to make that 5 a 0. Negative 5. Yep. So we're going to take negative 5 times the second row, and we're going to add it to the third row. If there's anything with a fraction, I'm just going to use the calculator to figure out the fraction for me. I'm not going to deal with common denominators or anything like that. All right, so negative 5 times the second row, added to the third row. And that will replace what's in the third row. Rows 1 and 2 are done changing for this problem. They're done. All right, so let's copy rows 1 and 2. There is still a good amount of copying. Just like when I did it yesterday, there was a lot of copying. There's still some copying, but at least there's no letters. All right, first couple we can do. So we're going to multiply everything by negative 5 and add it to what's in the bottom. What's 0 times negative 5?
0.
Plus 0. 0. What's 1 times negative 5? Plus 5. 0. Okay, so we only have one thing left we have to fix after this. What I'm going to do is use the calculator. So I need negative 4/7. Negative 4/7 times it by negative 5 and add it to what's below, negative 3. I can easily get this on the calculator just by pressing math. And the very first option can change decimals to fractions for you. So I just wanted the calculator to do it for me. Negative 1/7. And the last one. Multiply negative 1/7 times negative 5. And add it to what was below. Negative 1. So I get that. I think that's negative 2/7. I can just tell from the one up above. It looks like it's double. I'll check it. Negative 2/7. Okay, now let's look at what this last row means. Can somebody tell me what that? You could get a 1 here if you wanted. We don't need to. So we can skip getting that 1. But just tell me what this last row means if we change it back to letters. Yeah?
Oh, it means your x is 0 and y is 0.
It means 0x plus 0y. Yep.
Minus 1/7
Minus 1/7
equals
z equals what? Negative 2/7. So we've basically created an equation where the x's are gone, the y's are gone. The only thing left is a z. Let's solve that last equation. What could we multiply both sides by to get rid of that 7? Yeah? Yeah, we could multiply both sides by 7 times 7. That cancels those 7s. And that cancels those 7s. Negative z equals negative 2. So what's z? 2. There we go. Z equals 2. All right. Now, let's use, I don't know, let's use the middle one. 0x plus y minus 4/7 z equals negative 1/7. And let's see what we get for y. All right, so 1y minus 4/7 z minus 4/7 z equals negative 1/7. What's 4/7 times 2? What is it? 8/7. Yeah. 8/7 equals negative 1/7. How do we move negative 8/7 to the other side? Yep.
Plus 8/7.
Yep. Plus 8/7. And I said I don't want to deal with common denominators, but I don't need to. I already have one. It already has a 7 on both sides. So that's gone. Negative 1/7 plus 8/7. Well, common denominator is 7. What's negative 1 plus 8? 7. And what's 7 divided by 7? 1. So there's my y value. And my x value. I'll go back up to the top. X minus 2y plus z. Okay. So x minus 2y plus z. What was y? 1 plus z, 2. And that was equal to negative 1. Let's solve it and see if we get the same thing. What's 2 times 1? Yeah, I said yeah, negative 2 times 1. Negative 2 plus 2. And negative 2 plus 2, what happens there? Cancels out. We get x equals negative 1. So, is this the method I would use all the time? It depends. Depends on what the numbers are. For this one, I didn't like that we ended up with that 1/7. But if you don't end up with fractions, then this method is usually faster. When you get fractions, then it's just more arithmetic to deal with. But we'll try one more of those. But that's pretty much the pattern in every problem. Get a 1, get a 0, get a 0, get a 1, get a 0, you're done. You don't have to guess this last number to be a 1. You can, but you don't have to. All right, let's try this one. Don't think we end up with fractions when we do this one, so I think we might find this one a little easier. That first one we did, that's the hardest kind you would have, where you end up with a fraction. But this one I don't think we do. Alright, so let's write this as a matrix. What's going to be my top row? Just be careful when you write it. Yep.
1, 0, 1, 4.
1, 0, 1, 4. There's no y. So the fact that this is a 0, that's going to simplify a lot of the arithmetic. Multiplying by 0, that's easy. Okay, so that's good. 1, 0, 1, 4. Now, don't write the second row yet. Because does anybody notice anything? Well, you can reduce all of that by what? 2. So you could do 1, 1, 2, 5. You don't have to, but if we can have smaller numbers, the arithmetic's going to be easier. If you don't reduce it, you'll get the same answer. So 1, 1, 2, 5. And what about my bottom row?
1, 6, 8, 4.
8, 4. Okay, looks good. Any questions on that part? First step, get a 1 right there. Done. So we don't have to worry about that. If I didn't have a 1 there, like, don't write this. Let's say that was a 3. What I would do with this step is I would just swap rows 1 and 2. Because if I swap them, then I can get a 1 here without really doing any work. Okay. But this time, it already was a 1, so we're good. Next thing we want to do is get a 0 right there. So what could I multiply this number by and then add it to this number to make it 0? Yeah? -1. And if we do it here, we got to do it to the whole thing. So take the first row, multiply it by -1, add it to the second row, and that will replace what's in the second row. Now, if you wanted, you could just do that step. But I like to do both of these steps at the same time. This is the only time that I usually do 2 things at once. I want to get a 0 right here. What could I multiply the top number right here by, and then add it to this bottom one to make it a 0? Yeah.
-1.
It's the same thing again. Multiply the top number by -1. Add it to the third row. And that will replace what's in the third row right now. Okay. So, are we replacing anything in the first row?
No.
Never. The first row stays the same once you have a 1 here for the entire row. So let's copy that down. 1, 0, 1, 4. Now, multiply everything by -1 and add it to row 2. What's 1 times -1? Plus 1. 0. 0 times -1? Plus 1. 1. 1 times -1? -1 plus 2. 1. What's 4 times -1? Plus 5. 1. A row of 1s is great because that's easy numbers to work with, so that's good. No fractions this time right here. And something we need to do in the next step is already done for us. We've already ended up with a 1 right here, so this method is working perfect for this problem. All right, let's do it again. Multiply row 1 by -1 and add it to the third row. So 1 times -1? -1 plus 1. 0. 0 times -1? Plus 6. 6. What's 1 times -1? And -1 plus 8? 7. And 4 times -1? Plus 4? 0. The fact we got a 0 there, that means nothing. Okay, we got a 0 there, but I don't care about that. All I care about is the 1, the 0, and the 0. All right. What's the next thing we would want to do, but it's already done in this problem? It just happened automatically. So what would be the next number we would want to get, and where would we want to get?
Non-zero.
Yeah. You would want a 1 in row 2, column 2. The next thing to do, you get a 1, you get a 0, you get a 0. Then you get a 1 here. In the last problem we did, this number was a 7. So we had to multiply by 1/7. This time, it's already a 1. So we don't have to do anything. Leave it. It's a 1. That's good. So now, what's the next thing we want to do? Get the 6 to the 0. So what could I multiply this number by and then add it to that number so I get a 0? Negative 6. So we're going to do negative 6 times everything in the second row. And we're going to add that to what row? Row 3. And that's going to replace what's currently in row 3. Yep. So what row is not changing this time?
One.
Row 1 and 2. 1 and 2 are done. So just copy them over. 1, 0, 1, 4. 0, 1, 1, 1. Okay, so negative 6 times everything in the second row added to the third. What's negative 6 times 0? Plus 0. 1 times negative 6? Plus 6. Good. 1 times negative 6? Plus 7? This could be working on any better. What's 1 times negative 6? Negative 6 plus 0. Okay. So what does this last row tell me? It says 1z equals negative 6. Done. Z's over. How about this middle row? Can someone just read that one back to me?
X plus z equals 1. Y is 1. Z, sorry.
0x plus y plus z equals 1. And what did we just figure out z is? Negative 6. Y minus 6 equals 1. So what's y? 7. There you go. And now, how about the top row? What does that one say? 1x, yep, plus 1z equals 4. We just got z is negative 6. So x is 10. This problem was perfect for this method. Everything worked out pretty much as good as you could. No fractions. And things that we needed to happen happened automatically. Like getting a 1 here. We got all 1s in this middle row. That made the arithmetic simple. We didn't have a 1/7 this time. But that's a perfect problem for this method. Any questions on that? Yeah.
Oh yeah. So if I solve it the way that I know how to solve it.
Is that the way where you get the zeros above and below?
Yeah. Because that's how Mr. Babb ended up teaching me last year.
You can do it that way, yes.
Okay. So then I would just make whatever like my 1 right here is just the outside number over here.
Yeah.
Okay.
So he's talking about going a little bit further than this. Like we stopped here and then we did substitution. You can avoid this substitution if you work your way back up now. So we got zeros. Well, I shouldn't draw it like that. Draw it like this. We got 1s on the main diagonal and zeros below. Now he would work his way back up and get a 0 here and then get a 0 here, going back up. We're not going to go back up, but you could. We just finished with substitution. Any questions on them? Other questions? All right, so it's up to you. Does anybody feel like they need to see one more? Or I can give you some time to start the homework. It's up to you. Maybe, right, you know what? Maybe this will be one of the homework ones, I think number 22. We'll do part of it together, and then I'll let you finish it. So we'll maybe do the first like 2 steps. Okay, what would be my top row? Zeros are great because arithmetic is simple with zeros. So 2, -1, 0, 0.
Would we not just swap the middle row and the top row?
I would have, yeah. I would have swapped the
Just
middle
take
row.
the one up there.
Yeah, if we want, we could just kind of like cheat and do that right now. It would be better to start this problem off by swapping these top two rows, so you end up with a 1 in the upper left. If you don't see that right away, that's okay. You're just going to copy the whole thing down again and then swap it. So if we swap it, what would that top row be now?
X plus 3y minus 2.
So just the numbers.
Oh, 1, 3, 1, negative 3. 1.
1, 3, -1,
Negative.
-3. So our middle row just became the top row. That's a swap. And the bottom row, what would that be?
0.
Yep.
3, 1.
3, 1, and 8. Now, that's perfect. We already have a 0 in this spot. That's never happened before. We needed to get a 0 there. We already have one. Good. So, the step where I normally do two things right now, I only need to do one. Just get a 0 right there. Row 1 and row 3 do not change this time. Just row 2. So, what would you multiply by? Tell me what you would do. -2,
Multiply that and add it to the second row.
multiply it by what?
-2.
So -2 times the first row,
And add it to the second.
added to the second. Good. -2 times the first, added to the second, replace what's in the second. Copy 1 and 3 first. Okay, just get that out of the way. And when you copy it, double check that you copied it right. Because if you make one mistake, the whole thing is messed up. Alright, 0, 3, 1, 8. Okay, so -2 times the top row added to the middle.
0.
1 times -2 plus 2 is 0. What's 3 times -2?
Negative 6.
Minus 1. -1 times -2. 2 plus 0. 2. -3 times -2. 6 plus 0. 6. Alright, so we've got a 1, we've got a 0, we've got a 0. That's great. There's two options here. You're either going to multiply everything by -1/7, which you could do, or you could try to get this number to be close to a 1 by adding a multiple of this number to it. And that would avoid a fraction for now. So does anyone see what we could multiply this row by and then add it to that number to try to get this to be close to a 1? Yeah?
2.
You could double this row and add it to that row, and it's going to make that number a lot closer to being a 1. It's going to make it a -1, but that's easy. Right? That's how I would do it. If you don't like that way, multiply by -1/7, but then you're going to have fractions. I would rather avoid the fractions. So let's do 2 times the third row, and let's add it to the second row. We've never done this kind of step before, but it's going to help us to get a better number in the middle without fractions. 2 times the third row, added to the second, and that's going to replace what's in the second row again. So rows 1 and 3, not changing. 1, 3, -1, -3. 0, 3, 1, 8. multiply by 2, and then add it to what's above. What's 0 times 2? Plus 0.
0.
That's why it was safe to do that, because I knew it wouldn't mess up this 0. It couldn't. What's 3 times 2?
6.
Plus negative 7. It's a way better number to have in that spot. What's 1 times 2? Plus 2? 4. And 8 times 2? Plus 6. So 16 plus 6 is 22. So, yeah, you're going to deal with a little bit bigger number here, but I'd rather deal with that than deal with 2 sevenths and 6 sevenths. All right, now getting a 1 here is simple. What would we have to do to row 2 to get a 1 in that spot? Yep, just multiply that entire row by negative 1. It's kind of a lot of work just to copy that all over for that one step, but I'll do it. And essentially, all you're doing is changing the sign of every number in the second row. 1, 3, negative 1, negative 3, 0, 1, negative 4, negative 22, 0, 3, 1, 8. And this is our last step. And then we're going to know what z is. I got my 1, I got my 0, I got my 0, I got my 1. What's the last number that I want to change, and what do I want to change it to?
1, 0, and then third row, second column.
Yeah, I want to get a 0 right here, and then I'm done playing with my matrix here. Now we're just going to use substitution. What would you multiply this number by, and then add it to that to make a 0? Negative 3. Negative 3 times the second row, and then add it to the third row. Okay, what rows are staying the same?
1 and 2.
1 and 2. So let's just copy those over. Row 2, 0, 1, negative 4, negative 22. Okay, multiply by negative 3, and then add to the bottom. What's 0 times negative 3?
0.
Plus 0.
0.
Of course, that should stay 0. What's 1 times negative 3? Plus 3.
0.
That's good. Negative 4 times negative 3? 12 plus 1?
15.
13. What's negative 22 times negative 3? 66 plus 8.
74.
74. Okay, and I'll get z, and then that's where I'm going to stop. What does this last row tell me? Yeah, 0x plus 0y plus 13z equals 74. And how would you solve for z? There you go. Z, I don't think it's a nice number this time. 74 over 13. What is it? Oh, it doesn't. It's not a nice number. So we're going to just leave it like that. And then we'd go back to your top equation, which I'm just going to write it, but I'm not going to do it. That's your middle. 1y minus 4z equals negative 22. Just plug that number in, and I would just use the calculator to do it. Is there any question on how I use that button on the calculator to change decimals to fractions? How to do that again? All right. Well, I'll do it right here so you can see. Negative 4 times 74 over 13 times 74 over 13. Let's see what it gives me. Okay, it gives me that. If I want that as a decimal, press math, go to option 1, which is fraction, and hit enter. It's negative 296 over 13. That was negative 4 times 74 over 13. And then how would you put that negative 296 over 13 on the other side? You'd add it. I don't know what it's going to be. I'm not going to do that by hand. I don't want to do common denominators right now. So just use your calculator and take negative 22 plus 296 over 13. That's the decimal. And how do I get the fraction? Math. Fraction. And then hit enter. 10 over 13. Right, and I'll leave x for you to find. Right. Any questions on that? All right, so we got through everything. That was good. We did 2 extra examples I wasn't planning on doing. You need the top one?
Yeah, I just need the first.
There's your top. So we can end up with basically special cases. What I'm saying here is we're not doing special cases with matrices. We could end up with no solution or an infinite solution. That's not going to happen. Every problem is going to work out just like the 3 that I did. So no special cases. All right, let me double check. So those are the problems. 1 through 6, 17, 21, and 24. No, none of these are. 17, 21, and 24 are matrices. This is a 2 by 2. This is a 3, and this is a 3. You'll see 1 through 6. 1 through 6 is pretty flat.